All right, welcome to The Explainer. Today we're diving into the secret personalities of two of the biggest players in chemistry, acids and bases. And forget memorizing a bunch of formulas, we're going to figure out who they really are by just watching them in action.
Okay, so what really defines these two? Well, it all comes down to a really simple question. What happens when they bump into other substances? You'll see that their entire identity, everything they are, is about interaction.
So to really get a handle on them, we're not going to get bogged down in complex formulas. Nope. Instead, we're going to look at how they behave, how they interact with everything around them. It's almost like we're profiling two very distinct characters in a story. And here's the crucial point. We know what acids and bases are by seeing what they do. Their properties aren't just a boring list of facts. They're more like a script for how they're going to act when they meet other chemicals.
And this chart, it pretty much lays it all out. It shows their distinct, social circles. Each one has its own list of preferred reaction partners, and now we're going to explore those interactions one by one. So let's start building our first profile. We'll kick things off with the acid, and just watch what happens when we introduce it to a few different partners from its list. Okay, this one is a classic. It's one of their most energetic reactions. See, when an acid meets a really reactive partner, like an active metal, think zinc or magnesium, it doesn't just sit there. Oh no, it gets right to work. This whole interaction follows a super predictable three-step dance. The acid starts dissolving the metal, things get pretty vigorous, and in the end, you're left with two totally new substances, a salt and those telltale bubbles of hydrogen gas. And now for what you might call the fizzing reaction. This is an absolute signature move for acids. You might have even seen it in your own kitchen. It's a dead giveaway that you've got an acid on your hands. And this predictable outcome, making a salt, some water, and a whole lot of carbon dioxide bubbles, is exactly why vinegar fizzes up when you mix it with baking soda. The acid is just doing its thing, reacting with the carbonate and putting on its classic show. Now, here's where things get really interesting. You start to see a pattern. Acids have this consistent way of reacting with a whole family of substances. The partners might look a little different, but for the acid, the goal is always the same. So whether it's a simple base, a metal oxide, or a metal hydroxide, the acid kind of sees them all in a similar way. It reacts with them to neutralize their properties, which, as we'll see, is a huge part of its identity. So, let's sum up the acid's personality file. It reliably reacts with metals to make hydrogen gas, it hits carbonates to create carbon dioxide, and it goes after all kinds of bases to produce simple salt and water. Pretty consistent character, right? All right, time to switch our focus to the other key player in this story. Let's build a profile for the base and see how its unique set of interactions defines its chemical character. Okay, and this first reaction is fantastic because it's a perfect mirror image of what we saw earlier. Remember how acids react with metallic oxides? Well, bases do the opposite. They prefer to react with non-metallic oxides, stuff like carbon dioxide. They really are total opposites. And would you look at the result? Notice the pattern here? The products are a salt and water. That should be sounding very, very familiar by now. It's that classic outcome whenever acids and bases get involved. Bases also have a more specialized role. They have these unique interactions with certain types of salts, where they basically act as powerful chemical changemakers. Now, the chemistry here is a little more complex, but the main idea is simple. A base can react with salts like ammonium salts to release a completely new gas and create different substances. It just goes to show how they can break apart and rearrange other chemicals. So here's the base's profile. It creates salt and water from non-metallic oxides. It has these special relationships with certain salts, and of course it has that one defining reaction when it finally meets an acid. And that brings us to the most important interaction of all, the main event. The chemical showdown. What happens when our two main characters, the acid and the base, finally come face to face? It is the single most defining reaction for both of them. It's like their destiny. When an acid and a base combine, they do this little chemical dance that results in two of the most stable, simple products you can imagine, a salt and plain old water. This is so fundamental it gets its own special name. That's right, neutralization. This is the climactic scene in our story. They meet, they react, and poof, their distinct, powerful properties just vanish. And this isn't just a lab trick, it's how an antacid uses a base to calm your stomach acid. They literally cancel each other out. So,
After all that, after profiling these two fascinating chemical personalities, what's the big takeaway from our story? What have we really learned here?
Well, the crucial point is that their identities are completely wrapped up in their relationships. They are defined by what they do and who they do it with. You really can't describe an acid without talking about a base, and you can't describe a base without its opposite.
It kind of leaves you with a fascinating thought, doesn't it? If their identities aren't fixed but are defined by their reactions with the world around them, it's a powerful idea from chemistry. It suggests that what something is determined by what it does in relation to everything else.